Continuing with the problems, I will actually only solve part A because I'm not sure how much interest there is in solving all of these. So if you're interested in the solution to any of the others, then perhaps write a comment or something. But for now, I'll only solve part A. Now, for part A, I'll suppose that the limit of f plus g is L, the limit of f is m, and the limit of g is n. We'll suppose that we're approaching a point x naught, and what we want to do, what I'm going to do, is show that m plus n satisfies the limit statement for f plus g. That'll mean that it's the limit of f plus g, which is L. So that's how I'm going to do this, is show that m plus n satisfies the limiting definition for f plus g. Because this is m, this is n, this is the thing that satisfies the limiting definition for f plus g. Okay. To begin with, it seems like if we're going to scrutinize the goal, which is to show that f plus g minus m plus n in absolute value is less than epsilon, that's the goal, it makes sense to take the two things that we know, f minus m and g minus n in absolute value. We know that those are the limiting statements, and we can bound them by some epsilon. So it makes sense to just add them and think that there's some way to manipulate this and get the statement that we want. Well, the way you manipulate this is something you may not have heard of. It's called the triangle inequality. And it says, and for all of these proofs, you will want to get very familiar with the triangle inequality. They come up in epsilon-delta proofs very, very often. And it says that if you sum two things in absolute value, it's potentially smaller if you put everything in one absolute value. And the reason is because maybe some of these quantities are negative, and therefore when you sum them without the absolute values applied early on, then you'll get negatives and positives canceling each other out, and you might be getting a smaller quantity. There are other geometric explanations of the triangle inequality, but I'll leave it at that. And after using the triangle inequality, you can rearrange to get exactly the thing that we're looking for. This is the goal, right? Especially if I write less than e, you see it as the goal. So how do we exploit this? Well, we know that there exists a d1 for f, bounding it by epsilon over 2. Now, why epsilon over 2? Well, I know that I could choose any arbitrary value here. It doesn't always have to be epsilon, although that's standardly how we represent an arbitrary choice. But I could also represent it as epsilon over 2, because this has to work for any choice that I make over here, even epsilon over 2. So I know that there exists a d1 implying this and a d2 implying this. So if I take d to be the minimum, then both of them will hold at the same time, right? Because if it holds for d1, it holds for anything less than d1 as well. And by making that choice, I then get that the sum of these two things in absolute value is epsilon over 2, or less than epsilon over 2 plus epsilon over 2. I know by the triangle inequality that I can fit this thing underneath it, showing that it is less than epsilon. And there's the proof. Okay, for the final proof, we will show that if f and g are the same except possibly at x naught, then they have the same limit. And this kind of justifies why in those rational functions, if you can cancel a factor, then it has the same limit after canceling the factor. And that's because so long as you're not picking the point at which it's 0, then you can do the division and therefore you can cancel. So this is kind of the proof that that is actually a legitimate thing to do. Now, the proof is really straightforward. If we say that L is the limit of f, and we pick any arbitrary e and the corresponding delta, epsilon and delta, then absolute f minus L, now I'm suppressing notation, there's really an f of x here, but since they are the same, then by making the exact same choice of e and epsilon and delta, oops, this should be delta or d, by making exactly the same choice, then if I pick anything other than x naught, right, that's what I would need to plug into G for the limit definition, then it's exactly the same thing as f, and therefore will be bound by epsilon just like f is, and that's the proof. So moving on to new topics in the next video.